Hey everyone and welcome back. In the previous video we have learned how to add our room screen and add our view model. So now it's time to set up the basic of the WebRTC. To do that, I'll create a package named WebRTC and I'll copy and paste some classes because it takes too long and I've done it multiple times. So I'll simply just walk you through it and explain to you what is going on instead of writing down the codes over and over again. So let's take a look what we have implemented here so far. We have one of the main classes of our applications is named WebRTC Factory, which is responsible to create an RTC client. So let's take a look what we have to do initially when we create this one. As soon as we create our WebRTC factory or use the dependency injection to create an instance of it, you can see inside this init block, which will call automatically when the object is created, we will init the peer connection factory. So let's take a look. Inside it, we want to initialize the peer connection factory. It asks us some options about how you want to set up this peer connection factory. And then we are good to go. So we have to set up our peer connection factory at first. And then we want to provide some iServer and base context. And then we will have a function, a way to create our peer connection factory. So whenever this lazy variable is called, it's going to use the create peer connection factory and create our peer connection factory. So it's totally different from the initializing. It's creating the peer connection factory. We want to use peer connection factory builder class to set video decoder and encoder factory to the default one, and also we want to set the network monitor and disable encryption to false, and then we will create it. So using this lazy variable, we are able to create our peer connection factory. And after that, using this peer connection factory, we are able to do everything. We are able to create our video source, audio source, our peer connection, etc. So we will have some functions responsible to do some, basic needs of the video call applications or video call protocols. The first one is setting up a surface view renderer. To set up a surface view renderer, we will use the init surface view. It's going actually to use the init function using that surface view class and set up with the GL base context. So the next one is actually a start local video. This main function inside my WebRTC factory is going to prepare the local stream, and you can check we are creating a surface texture helper, and then using a video capture, we will create a video capture with this function that is going to use camera 2 enumerator, and using the back camera, you can make it front camera and give it back to video capture. Then we will initialize the video capture. It means we prepare it to record using surface texture helper and local video source capture observer, and then we will start capturing. It means we will open the camera to capture. Using that video capture and passing to local video source, which is right here, we want to create our local video track. Using peer connection factory, we will create the video track, add the ID and video attached to it, and using that video source that we attach the video capture to it, we will create our local video track and then add the preview to the surface that is going to start this whole local streaming. And then after that, we want to create our local audio track. So right now we have both of a video and audio track. The microphone and the camera is open now. We want to create a stream named local stream. So we will use the peer connection factory and create a local media stream. add the ID to it, and add both of the local audio track and video track to it. And then we want to notify that, hey, whoever is using this function, the local stream is ready, and here is the local stream. Okay, so far we have learned how to create the local stream, but we don't know how to create the peer connection. So I have another function here that is going to get an observer of type peer connection observer and a callback, which is this one. This callback is responsible whenever the peer connection wants to send some message to the target. Okay. So using these create RTC clients, we will use the peer connection factory and create a peer connection. Using this function, we will pop up an interface or a model. We have to create a class like this one that has some function like this to answer, and these are the basic functions about WebRTC to set up the point-to-point or peer-to-peer connection. And here's the implementation of it inside this class. We will get to that. Right here, we first create a peer connection using peer connection factory and add the iServer to the configuration of the peer connection and pass the observer to it, and add the local stream if it's publishing. So let me add is publisher mode. It's a boolean. So we first check if is publisher mode true. We want to add the local stream to it. Otherwise, we don't want to do it. And then using this created connection, we want to create the RTC client implementation, which is this class that is going to receive the peer connection and the callback. And we drop it out of this function. And there's an onDestroy function, which is going to dispose the local stream and video capture to close the video source and the microphone and everything else. So this is our WebRTC factory class. Now let's go and check what is inside this RTC client class. This class has the basic fundamentals of the WebRTC peer-to-peer call. So I've explained everything with details, that why is our data model is working like this, why we send it as a same feed to the media stream server, just like that. Inside my Twitch clone course, I'll add it here again, but I'll go from top to bottom again to make sure everything is okay with you. We will have a peer connection that is being received from the constructor. We want the mandatories of receiving videos and audios added to our media constraints. So we have implemented the functions. We know always the offer is being received from the server, so we will only have one function for sending the session description, which is going to be answer. Whenever we receive the offer, we want to accept the offer and send back the answer, so we will create the answer and set the local description to our peer connection. Also, we want to send back this description and give it to the media server as the remote description. So right now we want to update our remote media server message model. This message model is going to be sent to our media server. You can see the comment of it or the type of it is going to be answer. And right here we want to set the SCP, the session description of it, to the current generated message description, which is type of answer, and here's the description that is generated locally from our peer connection. And then we will wait 3 seconds to gather the ICE candidate out. As you can see, I'll add the comments here. In the meantime, that the ICE candidate is being generated using that peer connection, you can see we will have a function that will add the ICE candidate to peer connection itself and add to the candidates data structure of this remote message model. Simple as that. And whenever the 3 seconds is passed, and we will fire the callback to we want to send this message model to our media server using this one. So we will see later the implementation of it. So whoever is responsible to create this class is actually responsible to manage the generated ICE candidate or received ICE candidate later. Okay, so far so good. We now know how to create our WebRTC clients and set up our local stream. It's now time to proceed and use this inside our view model. So let's move to the next video and set up the local stream and the connection to the media server. So till the next video, see you everyone.